Okay, so what I set up was two graphs. One of them is going to be for our sine, and one of them is going to be for our cosine. And what's going to happen is we're going to take a look at our basic sine graph, which I'm going to do in pink, just like I did in the last one. And I'm going to do a basic cosine in blue, just like I did on the last one. So we're going to take these basic values from our unit circle, and we're going to refill them in here and replot, because we want to focus on what sine looks like, and then we're going to look at the reflection in the x-axis. Now, how do I know it's a reflection? It's got that negative in front of the function. That's what a reflection in the x-axis has. It's a negative of the f of x, or a negative of the function, just like we did in transformations with our parent graphs. So for sine, remember that sine comes from unit circle, and that's all of the y coordinates. So we're going to bing, 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 bing around at 0, then 1, then 0, then -1, then 0. And we're going to plot the sine, basic sine here first, so that you can see the difference. So we're going 0, 0, 90 is at 1, 180 is at 0, 270 is at -1, 360 is back at 0, and again, sine curve is a sideways S. So it should look very smooth. This is sine theta all day. Now, when we reflect in the x-axis, basically all the points that are above the x go below, and all the points that are below go above, right? And this negative is going to help us do that, because all we need to do is multiply all of these values by -1. So -1 times 0 is still 0. -1 times 1 is -1. -1 times 0 is still 0. -1 times -1 is +1. And -1 times 0 is still 0. So what's cool about the sine graph, when I do reflection in the x-axis for sine, it basically makes it look like an infinity symbol, but it's going to begin at 0, and it's going to move down first. So that negative on the outside reminds us, you know what, we're going to start at 0, and then we're going to move down and follow the same pattern, just in reverse. Okay, so that's how you do a reflection in the x-axis and what it looks like. So our equation is y equals negative sine theta. So if you have a negative in front of the function, that is a reflection in the x-axis. Let's go ahead and we'll put this down and pull up the blue. Cosine represents all of our x coordinates. Here are our basic 5. Starts at 0, 1. Goes to 0, then -1, then 0, then 1. So as I plot the regular cosine curve, I'm at 0, starts at 1, goes to 0, then to -1, then to 0, then to 1. So this is the U-shaped one. That waterfall and under, that waterfall and under. Make it nice and round and pretty, no points, and no straight lines. That's not what we're doing. This is very curvy here. And when we are looking for a reflection in the x-axis, what we're looking at is all of the points above the x-axis to go below, and all the ones below to go above. So the ones that are at 0 stay at 0, obviously, or we could multiply our regular heights by -1. So -1 times 1 is -1. -1 times 0 is 0. -1 times -1 is +1. -1 times 0 is 0. -1 times 1 is -1. So basically what happens is, for cosine, instead of it starting at 1 and moving down first, it's going to start at -1 and move up first. So these values are going to flip from top to bottom, but the zeros stay anchored. Now, we got to make sure we make a nice round mountain. Okay, nice round mountain. So instead of it looking like a U shape, it's going to look like a mountain. okay, where it starts off and scoops up and then over and then down and under. This is our reflection in the cosine graph for x, and this is our negative cosine theta graph. That's what it will look like. So anything that for sine that starts up and does an S is going to be a positive sine theta. Anything that starts and moves down and makes an S will be a negative sine theta. For cosine, if it makes a U shape, it's going to be positive cosine. If it makes a mountain shape, it's going to be a negative cosine theta. That is your lesson on reflections in the x-axis.